So this is that. Today we are now going to do question 4 of 2019. So now we are going to talk about sets of points, which may or may not be in S. There may be such points which are nearest to the point. Got a unique point on S which is closest to A, B. So let's talk about A squared plus B squared greater than 1. Now let's write down the other case. This case is actually easier. This is just A, B. For the other case, we have to look into a little further. Now, what's the Euclidean distance? That's right. That square root on A squared plus B squared. So we write that on the denominators. So describe an example on a subset S such as no point of S nearest to AB. There are so many ways. Like, let's try the open disk. So x squared plus y squared is less than 1. So basically, x squared plus y squared is less than or equal to 1 will look like this. But when it's just less than, it will have the whole disk. Yes, the whole disk, but without the boundary. That's why it is called the open disk. Let's remove these drawings and let's just pick a point. It could be any point you want. Let's just say 1, 1. And how about, such as more than one point on S nearest to AB. How about try the circle, the unit circle. Just to clarify, this is called a circle, while the thing inside is called a disk. Similarly, the surface of a sphere is called a sphere, but the inside of a sphere is called a ball. In mathematical terms, the n sphere is the sphere in n dimensions, while the ball is the ball in n dimensions. So enough of polytopes already. So there will be infinity of points. So let S denote the line expression of the distance of A being on a general point x, mx plus c of S. So let's try this. D squared equals to x minus a squared plus mx plus c minus b squared. There. And since we are now going to show that there is a unique point on S nearest to A, B. So this means that it's m squared plus 1, and we actually expand this plus blah blah blah. So this means that D squared has a minimum. So if D squared has a minimum, D also has a minimum. There. So we have proved it. And so for subset S, and for any point AB, the nearest point of S to AB is this. Describe the subset S. Because this is a rational number, so we are now going to write 2a plus 4b plus 1 over 5 equals to m a plus 2b plus 2 over 5 plus c. So m is obviously 2, and for c we need to look a little further. So minus 4 over 5 plus c equals to 1 over 5. Then c equals to 1. So this means S is the line y equals to 2x plus 1. Let me take out my notes first. So we are now going to show there cannot be two distinct points of S which are nearest to AB. Now any 2 points PQ in S, big S, the line segment PQ is also in S. So this means we are now going to show this. This is a bit more difficult to prove, but the gist of it is that it always has a minimum. So I've got any 2 points, free and Q in S. This means it can be anything as long as it's a closed surface. So it can be a circle, it can be a square, or it can be a blob. Whatever you think. So there cannot be two distinct points of S which are nearest to A, B. So we already found it for circles. Now let's figure it out for a square. Say square. Now as you can see, there is always a there is always just 1 point for every single angle. So this is a bit different from the MAT answers proof, but there is always a single point for every angle. Hence, there cannot be two distinct points as which are nearest to AB. So therefore, there is always a minimum distance when the norm, the square norm, the block norm, or the circle norm for complex numbers, or the hyperbolic norm for that matter, is greater than 1, because the 1 will, in this case, will be the closed surface. So let's draw a big blob here. It's actually a concave blob, but who cares? And let's draw a point. So this is the nearest point to S. So this is the nearest point to AB. So we are now going to draw a line on such points. As you can see, there's only 1 point which satisfies this. So therefore, there's always a minimum, and when there isn't a minimum, it must be in the curve. So therefore, we have solved the question, and we're done. See you!